Hi dear student, today we are discussing only first year questions from 2025 January 24 morning shift questions. Only first year all these are. Second year already we discussed. Now we can see. Process is non-spontaneous at freezing point but spontaneous at boiling point. Find delta H and delta S. So spontaneous at boiling point. Find delta H, delta S. They are asking at boiling point. So at boiling point, anyway, we have to supply the heat. That should be positive. Am I right? Delta G equal to delta H minus T delta S. This is our basic formula. Where heating means it is positive character. Anyway, delta H is positive. This is fine. To get spontaneous, delta G should be negative. When you will get delta G negative? When delta G is negative, then only spontaneous. So to get negative, this value should be very high. Means delta S also positive. When positive, then increasing temperature, then only delta G become negative. So delta S also positive. Then only at high temperature, delta G become negative character, then spontaneous. It is very basic question. They given balancing equation also, everything. So I can solve it. Equation also they provided. It is stoichiometric question. Fe3O4 plus 4CO gives rise 4CO2 plus 3Fe. So both they given 10 mole, 10 mole. So first find the limiting reagent. How to find limiting reagent? Given moles by stoichiometric coefficient 1. 10 by this is 4. Which is the smallest value, that is the limiting reagent. So this is smallest value, it is called limiting reagent. So according to equation, 4 moles will give 3 moles of Fe. Am I right? 4 moles of CO will give 3 moles of Fe. Then 10 moles will give how much? Given data is 10 moles. Then X equal to, you can find X equal to 10 into 3 by 4. If you want to get weight, you have to multiply into its atomic mass. What is iron atomic mass? 56. If you multiply this one, you will get option A. Very simple question. Very simple, just basic data you have to use. Which of the following will react with HBr very fast? In this case, intermediate is carbocation. Okay, intermediate is carbocation. Electrophilic addition reaction, H plus Br minus. So whenever H plus adding, then we'll get carbocation intermediate, which is a stable carbocation, we have to check it. So in this case, stability of cation, okay, positive charge stabilized by R cation plus M plus I, hyperconjugation you have to see. So in this case, suppose this pi bond is moving here. When we are adding H plus, this is will get. So here hydrogen, here positive charge. A positive charge, this positive charge is stabilized with back bonding. So back bonding stabilized cation is very highly stable. Very highly stable. So this is your expected answer. So B is your correct answer. Remaining also is there, but those are hyperconjugation and inductive effect. But resonance effect is highly dominated. That is the reason second one is the most fast reactor. So seventh one. In this case, H2O, ammonia and CH4. All central atoms are sp3 hybridized. Correct only this fact directly. H2O also sp3. Ammonia also sp3. But here 2 lone pairs, 1 lone pair. And CH4 no lone pair, sp3. All these are sp3. So statement A is correct. Order of dipole moment, it is also correct. It is more polar, more dipole moment. It is also correct fact wise. NH3 in H2O is basic in nature. NH3 and H2O are Bronsted-Lowry acid and bases. Ammonia is Bronsted acid they given. No, that should be base. So when NH3 reacting with water, you can get NH4 plus OH minus. Here H plus acceptor, it is base. So this is wrong statement. Bond angle H2O NH3 CH4 respectively. This is the correct value from NCERT data, exactly correct. So your answer is ABD. Got it? In Dumas method, which gas is evolved? It is direct question N2. So CXHY N2. You can find from NCERT this is. So Dumas method. You can see direct statement from NCERT. What is the gas we are getting? Z by N2. Z by N2. If you are heating with CuO, hydrocarbon which is contain nitrogen, finally I am getting N2. N2 we are estimating. So answer is N2. Direct question from NCERT. We will get N2 here. Next, find the most stable carbocation. To show the stability of carbocation, we discussed previous question also. We have to see plus M character and more resonance character. So here cation and resonance is there, but it is somewhat withdrawing character. But in the second case, resonance with lone pair of electrons also is there. If this is participating, it is also will participate. Second, in this case withdrawing group is there. Here no withdrawing, but here electron donating group and plus M group is. That is the reason second is more stable. We are expecting answer. When X grams of benzoic acid reacts with NaHCO3, 11.2 liters of CO2 is released at 273 Kelvin and 180 M. Calculate the mass of the benzoic acid. So benzoic acid, this is the formula. It is the test for benzoic acid also. When I am treating with NaHCO3, will get CO2 will be releases. CO minus plus Na plus will be there plus CO2 plus H2 like this will get. So 1 mole reacting, I will get 1 mole CO2. Got it? CO2 is from this, not from acid. Understood? So what the question they are asking? 1 mole will give 1 mole. Benzoic acid mass how much? This is 78. Its mass 78 plus and CO2 44. So what's the value approximately? 212, 122, 122 grams. So if I am treating 120 grams, I am getting 22.4 liters. Am I right? If it is 11.2 liters, it become by 2. 61 approximately. By 2, 61 grams. So 61. Or you can calculate assume X, then X equal to 112 into 11.2 by 122 into 11.2 by 22.4. It is 2 times. You will get 61 grams is your answer. Cross multiplication simply. Okay. So still more questions is there which I got source today itself. These are the questions I discussed, but still more questions is there. Thank you.